Another stream. Hello. How's everybody doing? Hi, Battery. Hi, John. I'm really sleepy. You're good? That's good. How does it feel to be good? So, you're not really in good shape right now. That's not good. I hope you feel better. Hmm. So today, we're going to be doing Advent of Code, which is just a bunch of little puzzles. And I guess I've been asked to do them with C++. And we're gonna see how this goes, because a lot of these are just trivia type things that I have not studied, and I've not looked, and I've not cheated. So we're gonna see at what point I get stuck. And hopefully it's not day one, because then I'll look like an idiot. Sound good? Full script, unwrapped challenges worth solving. What is full script? Running an essay through the night was not fun. No. No, it's not. Oh, and I need the ability to take notes. Twice? Like in a row? That's definitely not fun. Good luck, soldier. We're rooting for you. So, let's have a little read through on this first puzzle. The elves have good news and bad news. The good news is that they've discovered project management. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. The bad news is that they've realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. To save Christmas, the elves need you to finish decorating the North Pole. Collect stars by solving puzzles. 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains, due to new security protocols, the password's locked in the safe below. Please see the attached document for a new combination. The safe has a dial with only 1 arrow on it. Around the dial are the numbers 0 through 99, in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with an L or an R, which indicates whether the rotation should be to the left, towards lower numbers, or to the right, towards higher numbers. Then the rotation has a distance value, which indicates how many clicks of the dial should be reached rotated in that direction. So if the dial were pointing at 11, a rotation of R8 would cause the dial to point at 19, 8 to the right. After that, a rotation of L19 would cause it to point at 0. Because the dial is a circle, turning the dial left from 0, 1 click, makes it point at 99. Similarly, turning the dial right from 99, 1 click, makes it point at 0. Aw, that's fun. So if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 would cause it to point at 0. The dial starts pointing at 59. You could follow the instructions, but you recently required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. The actual password is the number of times the dial is left. Wait. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. Wait. The actual password is the number of times the dial is left pointing at 0. Okay. So we're counting how many times we hit 0. For example, suppose the attached document contained the following rotations. Following these rotations would cause the dial to move as follows, and so we hit 0 3 times, so the password is 3. Okay. You definitely fucked up your sleep schedule. That's not good. But, my semester almost ends, and I have free time to continue figuring out why did my transparency transform function keep bugging out? Why is your transparency function bugging out? That's not good. So, this puzzle isn't too bad. We got a dial with a bunch of numbers on it. I'm not going to go all the way up to 99, but it does. And so we get a thing. It points here. And then we're going to get an instruction like R4. R4. Actually, let's not do R4. R2. R2 means instead of pointing here, I need to be pointing 1, 2 to the right. And then I could get another one. Let's do 99. Another one like L3, which means that instead of pointing here, I should be pointing 1, 2, 3. Let's do that in like purple to the left. And so the goal here is every time we apply one of these transformations, we want to see if we landed on 0. And the password number is how many times we wound up landing on 0. That makes sense? So the first thing that I want to do is we're going to simulate the lock. So struct lock. And this is just uint8_teen current. And they said that it always starts at 50. So when the first letter is R, we go right that number of times. And when the first letter is L, we go left that number of times. Exactly. The only tricky part is this behavior. So like when we're at 0, left moves us back to 99. Let's implement that. So we're going to go void wrap. So let's do this. How are we going to do this? So while current is greater than 99, we're going to subtract off 99. And while current is less than 0, we're going to add on 99. Is that correct? So if we're at -5, -5 should be 95. Ooh, should we be adding 100? Let's try this logic and we'll compare it against their example and we'll see how it goes. Since we're doing this kind of, it wraps when it goes below 0 and when it goes over 99. This isn't the most elegant wrap function. I think the example that it should be 95. Yep. We only need to check the value after every turn. As long as it's at 0, we add 1 to the potential password. So actually, we're not going to make this wrap. We're going to make this turn. And so we're going to take an int amount. And so current is going to plus equal amount. And we're just going to have R make a positive amount and L make a negative amount. Okay. So do I want to deal with file loading? Or do I just want to put yeah, we're going to deal with file loading. So std if stream fin input.text. I'm going to hard code that. Input.text. And we're going to start off with the example input they gave us. There's no spaces that we have to worry about. Not, so based on what they're saying here, right, is they're only counting when, like, after the rotation, it lands on 0. I think. Because I'm pretty sure some of these are going over 0. But if it's not landing on 0, I don't think they're counting it. So while the file still has stuff in it, we're gonna make a char for direction, and we're gonna make an int for value, and we're just gonna fin direction value. And then we're gonna have a lock. And we're gonna make direction equal direction equals L. So if it's L, it should be -1, otherwise it's 1. Yep. And now we're going to go lock.turn direction times value. And now we're gonna have uint8_t password equals 0. And after it's turned, if lock.current equals 0, password gets increased. They, yeah, so they have an example, and then I'm going to download the example from me. Like, so they give us this example, right? But I push this button and they give me a big old list of randomly generated inputs, and there's like 1,000 of them or something. So like, it's basically impossible for someone to calculate it by hand. And so once we get their example working, I'm gonna give it the real value. The first time You even hear this? I won't be good at it. It makes you feel any better. I'm not good at it. Let's make the world's smallest CMake file. CMake dynamic fired version 921 projects AOC C++ add executable day1.cpp. And now let's debug this. You're just a uni freshman who know a tiny little bit of C? That's fair. Oh, the file's bad? Oh, because we're running from build. Boom, 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 boom. Okay. So we got L68. Direction should be -1. And after all that, current is 40. I checked. So yeah, we start at 50. Lock has 50. We're getting directions, right? And L means we should be decreasing. And we successfully got the 68. And so current is 50. Now it's 40. Where did I mess up? So current is 50. Because I'm using an unsigned. That's where I messed up. We'll just use an int, I think. That should be big enough for everything we need. You're barely in high school and I'm hoping to get good. Hello, Mr. Coffee. How are you? Thank you. Did I pronounce that right? Or am I on the perpetual pain of pronouncing every name I see wrong? So we got L68. And when we update current, we're at -18. Now we add 99 onto that. 80, and they say we should be at 82. So I think I'm right in that this one should be 100. You don't know how to pronounce coffee, by the way? Don't ask you. I mean, it's your name, bro. Am I wrong? So after this turn, we're correct. And we don't add to the password. Now the next one in the file is left 30. And after left 30, we should be at 52. Cool. Do we have anywhere we go over? Let's just go down the chain. Um, y'all seem to be getting along well. That's good. So 52. Yes. This one, so the other one should, both of these should be 100. Okay. So 82, 52, 0, password plus 1, 95, 55, 0, password plus 1, 99, 0, password plus 1, 14, and 32. So that appears to be working how they say it should. So let's take our input file. You should drink less coffee. Don't like coffee or energy drinks or anything that gives energy. You don't like sleep. You're only allowed to drink 1 cup of coffee a day. You used to drink a lot, like 6. That's a lot of coffee. You like coffee, but only like espresso or cappuccinos. Being sleepy makes you not explain. Teach me your ways, master. How can I learn these dark arts? And when we're done, our output should be password is password. And if we give it a quick little run, password is int password. So our password is 239 apparently, is that correct? Our answer is too low. Six cups is a lot. You're looking code while crying to my own decisions. What decisions are you crying about? What are my current projects? Well, at the moment, I'm solving admin of code, but more holistically, I'm working on creating a framework. So like a game framework. So a very simple version of a game engine. That's the based answer to this question. You made a panda game yesterday. Battery, why have you told me nothing about this panda game? Battery, we need to talk. Pandas are the best animal. Battery, I need your panda game. Battery. Give me the pandas, battery. Give me the pandas. Also, why the fuck is this wrong? Let's make these greater than or equal to and see if that changes anything. feel like okay. How do I do mapping code? How do I implement angle wrap? I believe it's current minus, wait, we're doing integers. So I can just do current modulo equals 99, I believe. Cheap viewers. Hello, Mr. Bot account. How about you get banned? Bye-bye. Does anybody know English, though? Fun things are happening in chat. So what was the number sequence again? We start at 50. Negative 18. So if current is less than 0, current plus equals 99. So 50, 81 plus equals 100. I did not check current. Go bot account. No, don't root on the bot account. At least that's better than my STL2 bitmap with 2 rectangles overlapping, and I wonder why transparency doesn't work. I do have an order application problem, John. Because when you're doing transparency, the order that you draw things is important. You want to draw things from furthest to closest. Where am I in this? We're at 50. We're at 82. We're at 52. We're at... Fuck. Should we be moduloing by 100 then? We should be moduloing by 100. Which gives us numbers between 0 and 99. $82, $52, 0. Why didn't I not just start with modulo? We're dealing with integers here. We don't have to do weird float manipulation stuff. 95, 55, 0, 99, 0, 14, 32, and that means that the answer is 3, which is what they got. So let's put in the correct input. And what do we get? 239, but we already saw that 239 was wrong. It's too low. You wonder how many people click to like the bots? You'll never be able to understand OpenGL, SDL, or Vulkan. It's too much logic for my tiny brain. I believe in you. Don't believe in yourself. Believe in the me who believes in you. Also, that's true, John. You don't have to like understand all of Vulkan or something, right? You just have to understand enough to like do something. You're more of a CLI framework maker guy? Working with SDL sounds cool. I'm still an idiot, so I work with Raylib. At least Raylib is fun though. Oh, you're doing text. That's does their texture streaming API allow you to write pixel by pixel? You wanna ask something to everyone here? Like, what do you hate on Git? What do I hate on Git? Is it bad that I'm stuck on the first day? Merge branches but forgot to push previous comments. For AI, which is better, Python or C++ or Java? If you, yeah, that's the answer. Python if you make AI. Do I agree with C++ if you use AI? I don't. I'm not sure if I necessarily. I think the answer is just Python. Oh, in my opinion, C++. C++ is my favorite language. But I also have like a Stockholm syndrome relationship with it. As I die. I think C++ is the best language. But it's also like a flawed masterpiece. It has a lot of things that are bad about it. Also, it's an everything language, so there's a lot to learn. Also, it's a layered language, right? So they simplify the language by adding more features. So like they build on top of existing features to make a new feature that's simpler. And so there's like layers of stuff that you're just not supposed to use or learn anymore. So there's a lot of stuff in C++ that you had C++ in 12th junior what? How many junior colleges have you been to, bro? It was kind of loud on me. Okay, guys. Guys, I think I give up. I give up. We're gonna look up the solution. I admit defeat. We're stuck on day 1. So, what he's doing oh, he's not even he's just going current plus equals amount. So we don't even so in this solution, right? We don't even have like this block. We just have int current equals 50. And we're just going current plus equals direction times value. And then we're incrementing if current modulo 100 equals 0. Which gives me the same fucking answer. Oh. It was kind of what I mean, like I was learning new. I'm also glad to see so many people here today. It's pretty fun. What am I doing now, by the way? Is that aimed at me? Cause I'm stuck and I'm trying to look up an answer. C++ is not for first thing, it's for a real job. C++ is not for first thing, it's for a real job. Okay, I think C++ is a good first language if someone teaches it right. If someone teaches you either modern C++ or C with like a couple of extra additions, I think C++ is a really good first language. But if someone like tries to teach you all of C++, you're gonna die. How'd you forget about modulus? Because no one ever remembers modulus. That's why it's such a common interview question, because everyone forgets modulus. But C is fundamental, right? So C is the lingua franca of programming languages. That means that if two programming languages want to talk, they're going to be talking C. So from that perspective, yeah, C is fundamental, but a lot of things aren't based on C. So from that perspective, C isn't fundamental. Your first language was JavaScript. Yeah, JavaScript is a terrible first language. Any language that has like a book called The Good Parts is bad. AI says, being aware that there should be a book for C++ called The Good Parts. You're learning Python? So if you're learning Python, right, make sure that you're learning typed Python. If you want to do anything serious in computer science and you're not using types, you're going to be screwed. So make sure that in your Python, you know what types are and you're learning how to use them. As per the college syllabus for now. Can we send link? I don't know. What are you wanting to link to? I'm gonna lean towards no, probably. Am I having a cough/cold? My voice is different. I don't have like the bass boost that my YouTube videos have on right now. So that's probably what you're hearing. Like my YouTube videos go through a little bit of audio editing to make the voice sound nicer. And so what you're hearing now is like the tinnier version. Also, no, I don't have a cough or a cold. My throat is just like permanently fucked. Bad stream. At least you don't have to parse the input file manually. You can do like what I'm doing here with scanf. So you can do some pretty simple input parsing with C. You also know JavaScript. You're much better at web dev than game dev. Check this. It's your roadmap for learning. Oh, did you send a link that my viewer didn't pick up? You're working on your own libc and version control system? Have you looked at muscle libc? You're 16? Wow. I kind of agree with the learning by doing and tutorials slow you down. Like in education literature, like the big thrust right now is that active learning, so basically learning by doing, is the way to go. But there is a certain amount of if you know nothing, you can't do. So follow small tutorials and then go work on projects. And that's kind of the downside of my channel that I haven't done very well. I should be like injecting more ideas for projects people should go and do. I'm not sure if I should like go and retroactively inject some projects or what. Also, why is it why is it that I do the same? Oh, what did I set my initial count to? Oh, is it the password? You know what it is? I bet you that it's because I assumed the password size. I am so smart. SMRT. I am so smart. 1000,007. I am so smart. I wrapped my answer. And that's why it's too small. You can occasionally watch Soding Dailies VODs for fun. Experiment for myself too. Ooh. You're gonna try to focus. Turkey? Okay, what's the part 2 of the puzzle? You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman. Actually, and let's... Now that we've identified this, let's go roll back and check if my lock system was working. I had the right answer. I just overflowed my answer variable. You solved the question, you think? Nice. So what's the part 2 of the puzzle? You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. With the newer security protocols, please use password method binary hex until further notice. You remember from the training seminar that this method means that you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. So now, instead of just checking if we land on 0, we're supposed to check if a turn goes over 0. So I think easy way to check this is that we can save auto last equals current. We can save the value. And now we're going to return current is greater than last. How do we check if we're at 0? So let's actually do this. So we're gonna go auto before mod equals current. And now we're going to return before mod equals current. Does not equal current. So if we had to change, meaning we wrapped around 0, that means that we wrapped around 0. Or if current equals 0, then we hit 0. Admin and code is like a coding game. So now, instead of doing what we were, we're going to check if the turn passed over 0, we increment password. And let's try it on the smaller input again. So our goal is 6. We got 9. So we're being too... So the dumb way to do this is that we instead represent turn amount as increments. So bool turn 1, bool negative. So current last equals negative question mark -1, otherwise 1. And if current is greater than 99, then current equals 0, and we return true. And if current is less than 0, current equals 99. And then if current equals 0, we return true. And if we didn't return true, we return false. Int turn. And so now bool negative equals amount less than 0. Int times equals stud abs of amount. And so now 4 times int zeros equals 0. for size underscore t I equals 0. I is less than times plus I. Zeros plus equals turn 1 negative. And then we return zeros. And now password plus equals turning the lock. What the heck's going on in there? You understand the problem now? That's good. What the heck is going on in chat? I am lost. Password is 7. We counted. One too many. Let's make sure that the numbers in the lock are still correct. So we're at 50. And then we should be at 82. And then we should be at 52. 0. 95. 55. 0. 99. 0. 14. 32. 'Do we have one too many input in here? Let's count zeros. So 68. And we should be at 82 with 1 0. 52 with 1 0. 0 with 2 zeros. 95 with 2 zeros. 55 with 3 zeros. 0 with 4 zeros. 99 with 4 zeros. 0 with 5 zeros. 14 with 5 zeros. 32 with 6 zeros. And we have another direction after this. Uh, Be careful. If the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. Okay. What the heck is making your brain tickle in a good way? Should I be concerned? We might have an off by 1. So our answer might be 1 higher. And we're gonna manually account for that cause I'm good at these. 5820. We got a gold star. Are you proud of me, chat? We completed day 1. And it only took us a frickin' hour. Oh my. Okay, let's not do anything clever with pipes. You just noticed how much I have wrapping integer around? LOI? Lol? Good job. Get inside and take the elevator to the only other stop, the gift shop. Thank you for visiting the North Pole, gleefully exclaims a nearby sign. You weren't sure who was even allowed to visit the North Pole, but you know you can access the lobby through here. And from there, you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely there'd be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input they'll need to check. For example, okay. The ID ranges here are wrapped for legibility. In your input, they appear in a single long line. Okay. The ranges are separated by combas. Each range gives its first ID and the last ID separated by dashes. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 55, 64. Oh gosh. None of the numbers have leading zeros. Okay. So 11 to 22 has 2 invalid IDs. $95 to $115 has 1 invalid ID. 99. Okay. Okay. And so then we want to sum the invalid IDs. Okay. Yeah, the first one was pretty simple. I just got stuck on using too small of a type for way longer than I want to admit. So I think so we have ranges. So there's 2 things here. We have ranges, and so we want to consider every element in the range. And then I think the easy way to do this. Hi, Mr. Cool Guy. Oh wait. Why are we hiing? I guess I'll hi too. Hi. So we got a range. We want to consider every number in the range. And then our number, we can convert it to a string. So we'll get something like X, Y, Z, W, okay? As a string. And then we can split the string in half. And if the front half is equal to the second half, it's bad. And we take that number and we add it to our sum. So for our first order of business, we want day 2. So we want ranges. Ranges are going to be comma separated. And then each number is going to be dash separated. So int main, let's start with the parser. So stud fn, if string fn is going to still be /input.text. There should be a slash there. And we're going to include f string. And so now we're going to stud get line from fn, and we're going to put it into stud string range. We're going to go wow, there is a new range, and we're going to comma delimit this line. So each line will be split on a comma. So while there is a range, parser, no, you don't want to write a parser anymore? That's fair. So let's check stud cout range. I think that we might be missing the last one with this. So here's our input. And let's get rid of the wrapping. And let's switch to building, launching building. Oh, I guess first step would be, it would be helpful to say that we would like to build day 2. Also, let's set CXX standard 220. Pos equals min. I don't think we actually care too much about the ranges, right? Because we want to consider every element in the ranges. So we just want to parse the ranges and then use them as mins and max on a floor, and then do some operation on each number in the range. And we are processing day 2. Is that everything? Oh, hey, look, that's everything. How convenient. Okay. So now that we have the range, I'm just gonna go stud o string stream line is the range. And we're gonna go int min, int max, and char dash. So we're gonna go line gives us min dash max. Apparently it's an I string stream. Okay. And so now we're gonna go for, let's make these size t's. Size underscore t min, size underscore ti equals min. I is less than or equal to max plus plus I. And now we need to do our is it equal? Stood to string I auto s and if let's actually make this, let's split this off into a function. Bool is, they're called palindromes, I believe. Stood string s. So is palindrome. So if is palindrome stood to string I, then we want our sum to plus equal I. Is a 10 char buff size okay for test 1? What is test 1? You like palindromes? Welcome back, Mattering. So the is palindrome test. So s dot size modulo 2 does not equal 0. So if it's not an even length, then it's not a palindrome. Then auto first equals s dot subster. So actually auto half equals s dot size divided by 2. First equals 0 to half. Auto second equals s dot subster half to half to the rest. And now when we return first equals second. Did we solve the part? Yeah, we did solve the part 2 problem. So now we're on day 2. The solution I came up with was like the really stupid. We're just gonna count every turn. We're gonna break every turn down into like 1 element turns, and we're gonna count every time that we're pointing to 0. Now for day 2. I can guarantee that there's a more elegant way to do this, but this works. I'm not aiming for elegant solutions to these. I'm aiming for working solutions to these. Okay. So 11 and 22 are our first two. So let's check that we're hitting those. $11, $22. Cool. So I is 11. Now let's check. Is palindrome? Yep. Nope. 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 Till we hit 22, which is a palindrome. Cool. And stood see out. Some is some. Oh, they're days. Like, if you go and look, right, it says that it is day 2 gift shop. But if we go back and we look at day 1, right? Day 1 has a part 1 and a part 2. So there are very set words that the people have for these things. Each day has 2 parts. So we've done part 1 and 2 of day 1. Now we're working on part 1 of day 2. And let's check if when we run this, it gives us the number 127775554. That looks correct. So let's get our puzzle input. Bum, 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 bum. And let's see what our sum is. That's not a small number. Yay, we got a gold star. So the quickly discovers that there are still invalid IDs on the ranges in your list. Maybe the young alpha is doing other silly patterns as well. Now an ID is invalid if it is made only of some sequence of digits repeated at least twice. Oh gosh. Okay. So it has to be at least twice. Well, we now have to consider so we still have this half. We still have this first. So we're gonna call this. I'm gonna save this function for reference. We're gonna call this is permutation palindrome. I don't think that's a correct phrasing anymore, but it works. I also use Arch, by the way. Congratulations. And now we want to consider every substring in first. And if the rest of the string is just repetitions of that substring, then it is a permutation palindrome. So for size underscore ti equals 1, I is less than first dot size plus I. Auto sub equals first dot substring. We don't even need to be splitting this. We just need to be checking less than half. And I think this divisible by 2 check isn't helpful anymore. So s dot subster 0 to I. And now how do we check if the substring repeats? So what we can do is we can go wow. So auto and cat equals sub and wow and cat dot size is less than s dot size and cat plus equals sub. And then if concat equals s, we return true. And if for no case we found a permutation palindrome, then we return false. I believe. And let's check it on our small input. And let's see if the sum is correct. No. Let's give it the smaller input. 110 to 112, which should have 111 in it. And let's see what our code does on 111. Oh, the problem is this. Concat.size is less than or equal to size, I believe. So we get those numbers. 110 is not. 111 is not. 112 is not. Okay, there's a mistake. So 110 is not. 111 half is 1. So I guess equal to half. So 110 is not. 111 was not. Which one are you doing? Is the checking halves useful? So sub is 1. And cat is 1. And cat plus equals sub 1, 1, 1, 1, 1. Oh no. This should be less than. Less than was correct. So 110, 1, 1, 1. 1, 1, 1, 1, 1, 1, 1. If concat equals s, which it does, we should return true. Cool. You're coming for me? Oh no, he's coming for me. What do I do? So let's try our bigger input. If it makes you feel better, it hurts my brain too. And our correct number is 417-437-9265. That looks right. So let's try it on our big input. Let's grab that number, pop that in. Yang! That's day 2 done. Okay. What is our day 3 puzzle? You descend a short staircase. Is this beginner friendly enough? Ah! We'll get something out of it. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Sorry about that, and Elf apologizes as she tinkers with nearby control panels. Some kind of electrical surge seems to have fried them. Nope, there's no prize. I'll try to get them online soon. You explain your need to get further underground, but you could at least take the escalator down to the printing department. Not that you get much further than without the elevators. Without the elevators working. That is, you could if the escalator weren't also offline. But don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage rating, a value from 1 to 9. Make a note of their joltage ratings. For example, the batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. Okay. The joltage that the bank produces is equal to the number formed by the digits on the batteries you turned on. For example, if you have a bank like 1, 2, 3, 4, 5, you can turn on batteries 2 and 4, and the bank would produce 24 jolts. You cannot rearrange batteries. We need to find the largest possible joltage each bank can produce. Okay. In the above example, 987 can produce 98 by turning on the first 2 batteries. You can make the largest joltage possible by turning on 8 and 9, 7 and 8. I do have a Discord server. I think it is linked on my YouTube channel, I believe. At least my website is linked, and the website has a link to the Discord at the top. Um, um, how big is the puzzle input? Can I exhaustively search? So this is 100. Each line is 100. We have 200 words. And look, it's a chew. Hi, chew. Um, $100 by 100 by 200 is just 2 million combinations. Yeah, we can brute force that. Okay, so let's do the brute force solution here. So day 3.cpp. So our input looks something like this. So we have lines. How much memory is that? Well, I don't care about the memory. So They are talking about you in the day 3 problem battery. What we need to do is, given each of these lines, right, we need to find the biggest number that we can make in order from the line. And so I was checking how many possible total combinations they're giving me and if I can brute force the solution. I love programming. You can calculate 2 billion things in seconds, but 1 nanosecond feels slow. Also, I will be right back. Battery's making tea. Can I have some tea? All of your tea shall belong to me. Your first thought was to use an orang? I see. Interesting. Okay. So so we care about lines. So we're gonna start by getting line. So we need F string in main. Stud get line. Stud line. Stud if string f in dot slash input dot text. F in line stud string line. So while there is a line to get, we can default delimiter on new lines. Welcome back. While you guys are solving the problems, I'm just going to read what advent of code is about. Good luck. So now we have a line. And now we can brute force it. So for size underscore ti equals 0, I is less than line dot size, plus I, for size underscore tj equals I, j is less than line dot size, plus j. If I equals j, continue. So now we're comparing every character to every other character. And we're going to take a max, size underscore t max equals 0. F equals line I, S equals line J, so first and second, and then value equals F minus 0 times 10 plus S minus 0. And then max equals stud max of max and the value. And I don't need to break these off. We can just put line I, line J. And we need algorithm for max. And max apparently wants me to tell it what the types are. Cool. And we want the sum of the maxes. So once we've forced the max of the line, we're gonna go size underscore t sum equals 0. Sum plus equals max. Stud cout, the total is sum. You made a big decision. What is your big decision? And what is the correct answer? The correct answer is 98 for the first line of the input here. 98, 89, 78, 92. So let's check. Oh, first order of business, let's add day 3. Day 3, and let's build day 3. And let's debug day 3. I think you're gonna hit the sack. It's almost 2 a.m. here. Good night, Mr. John. Thank you for stopping by. Sleep well. So max is 98. Max is 89. Max is 78. and max is 92. And the total is 357. $357. Yeah, there's a part to it every day, bro. Okay. So I'm happy with that. So let's get our puzzle input. And let's let it chug. 2 million brute force solved instantly. And it's even correct. Let's go. The escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction of the system and hits the big red joltage limit safety override button. You'll count the number of times she needs to confirm yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. The voltage output for the bank is still the number formed by the digits of the batteries you turned on. The only difference is now that there will be 12 digits in each bank's voltage output instead of 2. That is heat death of the universe numbers. Can you check this? You want to know if I did something similar? Did you get the correct answer? Because if so, I did something similar. Um... Let's check the numbers on this. So 100 to the power of 12 is heat death of the universe. Okay. What is an algorithm? So, something that we know. What is a heuristic? Once I hit a number, so in this one, right? The leftmost number. So we have a problem here, right? The leftmost number is going to be bigger. The leftmost number is going to be bigger than every number to the left of it. Hello, Sheepkick. How are you doing this morning? Are you having a good day, Sheepkick? Do you go by sheep? I'm doing well. My brain hurts. I'm solving puzzles. Is that a Zlen? Eagle by sheep? Nice. Zlen is now here to watch me suffer. I see how it is. So, observation. The leftmost number that we pick is always going to be bigger than the numbers to the right of it. No. The leftmost number that we pick is always going to be bigger than the numbers to the left of it. And that gives us a pivot. Does it give us a pivot? Because we don't necessarily evenly want to space our 12 numbers around that number. Is there a way? So how do... I think there's a way we can linearly scan this. So I think the greedy heuristic is that we take the maximum number Is there any situation here where we're not just taking the max numbers? Yes. Because in here, we want to take 2s over here rather than 2s over here. So we want bigger numbers at the front and we want smaller numbers at the back. You feel like a hero reading day one problem? You need to save people? Wow. You need to save people by opening a door. You can decorate the North Pole. So let's start with the heuristic of drops. So when a number after me drops, I probably want to consider that number. So like here, right? When the number after drops, we want the 8 in. So I think what we do is we scan from the left counting up, and then as soon as we drop, we add that number. And that number we added, we then remove. So we do it again. Okay. Let's try. So we're going to have a stud vector size t of activated batteries. And so now for size underscore ti equals 0, I is less than 12 plus I. So we want to turn on 12 batteries. And the battery I want to turn on each time is counting from the left. So char last equals 0. So for size underscore ti equals j equals 0, j is less than line dot size plus j. If stud find activated batteries dot begin, activated batteries dot end, j does not equal activated batteries dot end, then we continue. So if we don't consider, never mind, gotta go. See you. Bye-bye. If the activated battery, so we don't reconsider any batteries we've already activated. Okay. And we want to be counting up. So when we're going up, we're good. So if line j is greater than last, so line j is less than last, then we're going to add j to activated batteries. So activated batteries dot push back j. No. J minus 1. And then we're going to break out of this inner loop, and otherwise last equals line j. So what I'm doing is I'm scanning from the left, and every time, so we're going to, I think Zlun and sheep might be here. And I'm going to be counting up. So as soon as I stop counting up, that's the biggest number, that's the biggest leftmost number. And I want to turn on that one. And then I'm going to stop considering that battery anymore, and I'm going to look for the next biggest leftmost number. So we're going to, our heuristic is just going to be biggest leftmost numbers. And once that's done, we're gonna sort. This should be a stud. It should be a stud vector of bools, activated battery, and its size is going to be line dot size. And we're gonna stud fill activated batteries dot begin, activated batteries dot end with false. Actually, doesn't vector activated batteries dot. I think it'll default initialize the false. And we're gonna go activated batteries J equals true. And then we're gonna go for size underscore t I equals 0, I is less than activated batteries dot size plus I stud string. Yeah, we'll do it by strings. I don't do I don't know, because I think you can look at last year's puzzles, I believe. So stud string total or value is gonna be empty. Which I believe we get by default. And so now if activated batteries I value is gonna plus equal line I. And so now the question is, what is the value of value? And sum should be equal to stud stud string value. And we're going to need to include strings, S string. Like I said, I believe you can look at the puzzles from like last year and a few years back. So I don't think they go away. I'll use string. Size underscore t value. Value string into value. Sum plus equals value. Let's see if that works. Let's do the smaller input so that we can track based off of them. Ba-ba-ba-bum. Value string equals 7. Okay, so I guess we gotta scan through what it's doing. So our line is 9. So last is 0. J is 0. We don't need to find anymore. We need to go if activated batteries J. Then we continue. And everything should be false. Yep. Um. So now last is 9. Current is going to be 8. And we don't want J to be turned on. We want J minus 1 to be turned on. So we're turning on 9. Now we're at 1, 0. We skip over 9. We consider 8. 8 doesn't draw. And we need to reset last to 0 every time. Okay. So we're turning on 9. We're skipping 9. 8 is bigger, so now we're considering 8. We dropped to 7. So we're turning on 7. We're skipping 9. We're skipping 8. Last is 7. So now we turned on 6, I believe. This point, no, 9, 8, 7 are all on. And every time through the loop, we should be turning the next one on. Um, and if we get through this loop, so we haven't had any drops, I think we want to turn on the last thing activated. So I want to stood find and activated batteries dot begin, activated batteries dot end. Or it's not find end. Stood find activated batteries dot reverse begin, activated batteries dot reverse end. And so I'm looking for the last false. And it should be guaranteed that this exists. And we're just going to set this equal to true. So bool found equals false. We're going to found equals true before we break. And I'm going to call this marked 1. So if we haven't marked 1, then we're going to set the last one to true. Last unmarked one to true. Or should we set the... I'm going to set the last... Ooh. Oh. So if we don't have a drop, that implies that the numbers are all the same. So we'll just mark the last one. You're using a browser ID to solve these. Do you think it's better if I just use VS Code? I don't think it matters. I think you should use whatever makes you most comfortable. True, 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 true. Now I got marked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So now we're interested what the value string is. Good. And the value is the same, and that gets summed, and we're happy. It's the value string for the next one. It's the correct answer. What's the value string of the next one? We broke. Okay, so let's just consider this line. And what is happening? So nothing is activated. Or not less. There hasn't been... Well, there should be a drop. Oh, we haven't had a drop yet. So we turned on the 4. Good. Now we reset everything. And we should be turning on the 3. Ooh. But turning on the 3 is wrong. So new algorithm. I turn on the biggest number. But I don't want just the biggest number. I want the biggest leftmost number. Is there ever a situation where the biggest number won't be in the number? I don't think so. Unlock my smart mode and listen to the Death Note theme song. Good job. Stood. Let's find the biggest number in line. So auto biggest is the max element of the line. How do I find the how do I remove deactivated from this max element? I do it by hand. So auto biggest equals 0 for size underscore ti equals 0. Not I, k equals 0. K is less than line dots. I'm already looping over. So I know what the biggest is. So char biggest equals 0. Um, if line and size underscore t biggest index equals -1. So if line j is greater than biggest equals line j, and biggest index equals j. But if activated battery is j, then we continue. So we take the biggest number that we haven't already activated. And if there's a tie, we take the leftmost one. And then activated batteries j, biggest index equals true. What is the length of line? The biggest index is 14. I'm on day 3, part 2. Okay, let's see if this works. We just take all the biggest numbers first. Which gives us... Or do we want the rightmost? Because I don't want the leftmost too. I don't know, is Len still with us? Let me take the biggest. I'm stuck. I give up. Actually, okay, let's think a little harder. We want the biggest leftmost. So what happens if for each character we subtract off its position in the string from its value? So auto value equals line j minus j. So the more right you are in the string, the less value you have. Or do we want the opposite? The more right you are in the string, the more value you have. No, we want the biggest leftmost value. So let's see what this gets us. An error. So let's try the other way, where we value the right more. There's no way that worked. What's the correct answer? 4, 3, 4, 2, 3, 4, 2, 3, 4, 2, 7, 8. Okay. Okay. And what is the total? 3, 1, 2, 1, 9, 1, 0. We're wrong. This algorithm's off somewhere. So what do we get for the first line? Correct. What do we get for the second line? said, what do we get for the second line? Correct. What do we get? Okay, but the value should change. It should be plus J minus the activated batteries up until now. So auto activated equals studs reduce. Leave me reduced by plus by default. So activated batteries dot begin activated batteries dot begin plus J 0. So plus J minus the activated. You want to copy and paste it into a file and then open that file. Let's check line by line again. Okay. 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 And for this one, we want to skip all those leading ones. So we just want 8, 8, 8, 9. Nice. Using the LF stream? Yep. The IF stream. Input file stream. And if we put these all together, U1219, we're still wrong. Wait. How are we wrong? Were any of them individually wrong? 987 65432. This one's wrong. Okay, I give up. Advent of code 2025, day 3 solution. What is the greedy algo for part 2? So we find the max of the line. What? Okay. So find the largest n-digit number. So we loop over the number we want. -s minus start pause. Oh! So we're taking... What he's doing is he's taking substrings. What the hell is this can skip thing? So he's taking the max digit, the leftmost max digit, and that's becoming the start position for his search. What is that can search part doing? So for each line, loop 12. Auto can skip is line.size. And then we have a stud string results. Result.size. And we have a start position, which we default to 0. Yeah. And n is 12. And then we have a search segment. So start is start pause. Auto n equals start pause plus can skip plus 1. So that means that our length is can skip plus 1. So we can stud string view line.data plus start pause, and the length is can skip +1. Auto search segment equals all that. And then auto max digit equals stud max element of search segment dot begin search segment dot end. We don't need a substring then. We can just go a start position plus can skip +1. I was close. Is this what cybersecurity students feel like? I don't know. Do I look like a cybersecurity student? And then auto best pause equals start pause plus stud find line dot begin plus start pause line dot end. And we're searching for max digit. So then we find the first place. And we need to go minus line dot begin. Start pause equals best pause +1. So result dot push back max digit. I have no idea what the hell is happening here. So now we have a stud I string stream value string from actually no. Yeah, from results. Let's actually yeah, we'll do it this way. And then we can have value string into value sum plus equals value. You're no student, you're the teacher. I'm gonna start this tomorrow because it's night and your brain is messed up now. My brain is also messed up. Send help. How the hell does this work? Someone explain this black magic to me. How? Huh? understand this can't get magic. It is morning for me right now. Although it's almost afternoon. Three, 1, 2, 1, 9, 1, 0, 7, 7, 8, 6. Okay. Okay. What's the solution? So I do inner star index remaining. Let me get our line started. Why are we subtracting off remaining? So top-down iterative dynamic programming solution. Maximal voltage with prefix bank 0 to L within budget B. So we're doing a big table fill for this one. So 0, all of the zeros. So we're filling the whole bottom of the table with the first character. And then we're filling the whole right of the table with 0. What is the greedy solution? I have no idea what you're doing to soothe your brain right now. Yo, Rosie lurking? Thank you for the lurk, Rosie. Wait, Rosie not streaming? Is Rosie okay? You're coding in CSS to soothe your brain? I see. If it works, then it works. What is the greedy solution? There's a greedy solution here. So we look over the bank. Loop over the bank. Remaining. Well, I'm going to declare that I made it to day 3 and then got stuck. Which is not a great number. What is the greedy algorithm for this? Can we factor the start? Mm. So we copy the values from the line into the bank. Which voltage is 0. We're going to loop over. So it is the line. We need 12. Oh, so the greedy solution is just you take the biggest number. What does this end it? But we don't. So we take the next biggest number, but only some number of digits out. In this case, that number is 3. It seems to be. So we have a sliding window, and we take the max element of that window. that's what can skip is doing here, is we're making this window. We can call this window end. Or no. Window size. And we can move a +1 at the end of this from in here. So now we found a 9 in the window from 0 to 4. 1 is the position of that 9. The window size is 4 again. So the next 4. I don't understand. So I don't understand how we can come up with this sliding window. This window size is magic. You're glad even masters get confused? I'm glad at least one of us is happy. So, what happens to the answer if instead of having... Why a window size of 4? So auto need to find or left to find is 12 minus result size. So our window size is how many things are left minus the start position. Okay. So that's that. This right here is remaining characters in line. It's the size minus the start position plus 1, actually. I don't know. Maybe. I think that's where the +1 comes in. So we have the window size of the remaining characters in the line minus how many things we... Because... Oh! So we can't consider the whole line because we need to find at least 12 characters. So Okay. I understand. So what we do is we go size underscore ti equals 0. I is less than 12. We're looking for 12 characters plus I. So we want to find the first 12 batteries. And so now we want a window. So stood string view window, which is going to be equal to the line, but not quite. We're going to do that out here, actually. So at the start, our window is the full line. But we want to shrink the window that we're looking at because we need to have 12, we need to find 12 characters. So the max length of the window, right? The window dot subster 0. And its size is window dot size minus however many we need to find. So how many have we found? Stood result, stood string result. How many we found is so auto already found equals result dot size. Or I'm not gonna say already found. I'm gonna say num found. Now I need to take the window size. We need to shrink it by the number we need to find. So still need to find is a number, the total number we need to find, so 12 minus a number we already have found. So window dot subster, the window size minus however many we still need to find. And then there might be an off by 1, so we might need a +1 in there. You can't help much, but one day you get like a millisubs. I'm gonna be good at coding too, so then I'll be your backup. Nice. I wish both of us luck. So now what we want is we want auto max number equals the max element of window dot begin window dot end, and that will give us a pointer to the max element. We want the actual max element. What does stood max element tell us about which one it gets? Because we want the first one. So it gives us the pointer to the first one. That's just what we want, so we don't have to do anything else. So auto max pointer equals that. So then auto max value equals star max pointer, and auto max offset equals max pointer minus window dot begin. So we found the first highest element. And we know its values. We know what the biggest digit is, and we know where in our window it is. And so then to update our window for next time, window is window.subster max offset. So basically what we're saying is that we're going to start at the thing we found. So that big number that we found is where we're going to start. And we're guaranteed that we still have space to find however many characters we need to find after that. And so we can go result dot push back star max pointer, because I don't actually need to save the max value. So we update window. So we shrink window so that we can still find, so that we will always find 12 digits. Okay. And then find largest digit in window. And window starts at largest digit. Starts after largest digit. We might need a +1 on here. We'll see. Because we want the window to no longer include that digit. So what's our input? That one. So at the start, our window is the full string. And then we're gonna say that we still need to find 12, so we're gonna shrink the window size. So that there's still enough room to find 12. The max element is 9. So our result is now going to include 9. And our window, need a +1. Our window is going to be considering the character after the 9. So our window is that big so that we can still find how many we need to find. And now we found the 9, so our window is everything after the 9. We're going to resize the window. So we need to find 11. So we're not going to use a string view for this because the string view can only get smaller. Stood pair size t. Actually, we'll just do struct window size t start end. So at the start, our window is 0 to line dot size. So our window is the whole string. Now, not touching the start of our window. We're gonna go window dot end equals window dot size. So we'll have a size function. Return end minus start. There might be an off by 1 layer. We'll have to see. So the end of the window is now there. And so now we're going to find in our line dot begin plus window dot start, and it ends at our line dot begin plus window dot end. So the window will now start after the largest digit. So window dot start plus equals this. Line dot begin plus no. Actually, window dot start equals max pointer minus line dot begin. What am I making? I'm doing some little puzzles. Every day going up to Christmas, there's a coding puzzle released. Actually, I think it's only halfway to Christmas this year. And so I'm solving some of the puzzles in the daily coding puzzles, if that makes sense. So the puzzle right now is that I have this string and I have to find the biggest number, right? So I have to remove some numbers so that this string is only 12 characters long. So like I might be able to remove that number and that number, right? And only by removing, I need to come up with the biggest number. So I have to basically find the biggest number that I can extract out of this string. Does that make sense? So we need to, I've identified that we need to have a window, right? So the goal is we have our string, right? So X, Y, Z, W, right? And I need to find 2 batteries, we'll say. So I have a window, which will be like this. And so I can only consider, actually, I can only consider this many because I need to be able to find a total of 2. So I can find 1 from this. Let's say that this is the biggest number. I start here, right? Which means that I get rid of this X. And now I move my window so that it doesn't include the number I found and just looks for these 2. And then I find the biggest number in here. So we'll say it's Z. And that means that my new number is YZ, which is the biggest number I could have pulled out. So let's do like an actual example here. So let's say I have the number 1, 4, 3, 2. Actually, let's do 2, 3. What's the biggest number that I can pull out of this by only removing and where I'm trying to get 2 digits? That'd be 43, right? 43 is the biggest number I can get. And I get that if I move the 2 and the 1. So how do I figure that out? So my goal is that I want to find 2 digits. So that means I'm going to have a window which is sized so that I can have access to 2 digits remaining. So I have to take the size minus however many digits I want. And so now we look in that window and we find the biggest number in that window. So 4. Okay. That means the 4 is part of our output. And now we're going to update the window, shrink it so it's just here. Okay, we don't update the end, we just update the beginning. And now we can retweak the end so that we're considering a maximum of 2 characters. So I don't need to save 1 character anymore while I'm looking for 2. So I can include that character in the window. And now what's the max of the window? Well, it is 3, right? So we're going to put 3 in the answer. And we already identified that that's correct. So we're looking for the biggest number in the window that still gives us enough characters left over to meet the number. So now our goal is, instead of looking for 2 characters, we're looking for 12 characters. So how many do I need to find at the beginning? Well, I found 0, so that means I still need to find 12. And so that means that my window is this right? Window.start plus window.size I still need to find. Let's see if this is right. So our window is 0 to 3. And now we find the max number in that, which is a 9. So we add that to our output. Our result is now 9. So we're going to update the start of the window to be looking at after the 9. So now 8. We found 1 digit. So how many do we still need to find? We need to find 11. So where can we end? Is that right? That's wrong. So we can end at line.size minus however many we still need to find. We need to find 12. So a window can end at 3. And so now we need to find the largest digit in the window, which is still 9. We put it in the results. And then we move the window start to be 1 past the 9. So we need to find 11 now. So the window can end at 4. And now, what's the max between 1 and 4? Should be 8. So now we put the 8 in the string. We update the start to be 1 past the 8. Now, we need to be able to find 10, so the window has to end at 5. What's the biggest number between 2 and 5? Should be 7. Let's add 7 in, update the window. So we still need to find 9. So we have to end at 6. So what's the biggest number between 3 and 6? 6. So we'll push that back and start after the 6. So now 4. How many do we need to find? 8. We can do one better here too. Instead of saying result.size is I. But it's whatever. 7. Now we find the biggest number in that range, which is 5. Put it on. Find the biggest number, which is 4. Put it on. 3, 2, 1. And now we start appending ones at the end. And when we check the sum of that against day 3, our number's wrong. Where? Which one are we wrong on? So let's put this one in. That one's right. Let's put this one in. I think that's why we have the +1 on the end of the window size. Because we're not catching the 9 there. So I think that +1 lets us catch the 9, and now we're right. And then this one, 4, 3, 4, 2, 3, 4, 2, 3, 4, 2, 7, 8. And now this one. 8, 8, 8, 9. 4 ones, a 2, and 3 ones. Which means that the sum of the whole thing should be 3121910778619. And that means that if we put in our input and take our answer, we're correct. Ay. What's the puzzle for 4? Let's just read it. I'm probably done, but we'll at least read the puzzle. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere. There's even a massive printer in the corner to handle the really big print jobs. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that, one of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. If we could break through the wall, you'd be able to keep moving. It's too bad all of our forklifts are so busy moving those big rolls of paper around. We can optimize the work that the forklifts are doing. Maybe they would have time to spare to break through the wall. The rolls of paper are arranged on a large grid. The elves even have a helpful diagram indicating where everything is located. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall of the cafeteria. In this example, there are 13 rolls of paper that can be accessed by a forklift. Okay. Consider a complete diagram of the paper roll locations. How many rolls of paper can be accessed by a forklift? This part I don't think is too bad. Why does it do this? Why does it just randomly decide that it's gonna turn off after some amount of time? I don't think I bumped the cable, so I don't think it's a cable bumping. I'm even kind of been keeping an eye on the input volume to make sure that I'm saying something. How long have I not been saying something for? Because I'm pretty sure I've been talking pretty constantly the whole time. I'm going to. Did I talk to Territory at all? Was I still talking then? Maybe it hates me? Thanks. Okay, so we're gonna make stood vector bool occupancy. So we're gonna go for char C inline. What does the map look like if there's an at? So if So occupancy dot push back, and we're going to go occupancy dot reserve line dot size. So occupancy dot push back, C equals an at. And then we're going to go occupancy map. In place back, stood move, occupancy. About like 5 minutes. Then territory left, and I thought you just shut up. No. Oh, so I did read out day 4? Good. Cool. When you went back to the CMake file, you weren't talking like right after you looked at day 4? I see. Cool. So not too long then. Occupancy map. So this should be building our map fine. So now adjacency map dot resize, occupancy map dot size, and then for auto reference row in the adjacency map, we're going to row dot resize, occupancy map 0 dot size. And we're going to make sure that we fill it with zeros. These questions are so ambiguous. What even classifies toilet paper adjacent to the forklift? So that one, there is a well-known definition of the answer to that. So when we have a grid of things, the well-known definition is that if I have an element here, right, so in the middle, then if we're dealing with 4 adjacency, these 4 things will be, let's do them in green. The 4 green things will be adjacent. But they said that we were dealing with the 8 adjacent items, which means we're dealing with 8 adjacency, which means that the corners are also adjacent. So the question does say, in the 8 adjacent positions, so that we know that we're dealing with 8 adjacency, which means that all of the green and blue dots are adjacent to the red dot. Does that make sense? So now we have the adjacency map resized to be the same size as the occupancy map. Just for shits and giggles, let's go for auto size underscore t row equals 0, row is less than occupancy map dot size plus row, plus row, or size underscore t call equals 0, call is less than occupancy map 0 dot size plus call. And then after each row, we're going to end the line. And after each call, we're going to go if occupancy map row call, then we're going to see out an ampersand. Otherwise, we're going to see out a dot, and we should be able to reproduce the map that they gave us. So let's switch over to day 4. Okay, I wasn't sure if it meant adjacency in a row or diagonal or in a column. Yes, it means all of the above. Each time you swear, remember swearing isn't illegal. Oh. This looks like the same map to you guys, right? Yep, it looks the same. So now we'll resize the adjacency map to be the same size. And now we're gonna do similar. So we're gonna do a kernel, which means that we're gonna look at every cell on the map. And now what do we want to do for every cell on the map? We're going to sum the number of filled cells around it. So we're gonna go size underscore t filled around. Just going to take the occupancy map as input, as well as a size t row and a size t column. And so now we're gonna do ranges. So min, auto min equals row. I gotta do size t, so it's gonna be ints. Row -1. Min row. And we're gonna take the stood max of that with 0. And we're gonna do the same thing with min call. And now we're gonna do the max versions. And we're gonna take the min of the row +1 with occupancy map dot size. For the rows, that's correct. We need to tell it that we're using ints. And for the columns, occupancy map 0 dot size. Okay, so this now tells us what we need to loop over without going out of bounds. So now we can just go for size underscore t row. We'll actually do x equals min row. X is less than max. Less than or equal to max row. Plus x. Now I'm going to do the same thing for y. But y is dealing with columns. And now we're going to have size t out equals 0. And if we're going to skip the current one, so if x equals row and y equals call, we're going to continue. Otherwise, if occupancy map x y, actually we're going to call these r and c. So r and c out plus equals 1. And then we're going to return out. And now we have occupancy map here. So adjacency map row call is going to have the value of build around from the occupancy map row call. I don't think it matters where the forklift starts. We're not actually doing much with the forklift. We're just identifying the papers that can be moved. So I have a sneaking suspicion that the next part of the puzzle will be taking into account where the forklift starts. But for right now, we just care about what pallets of paper can be moved. So we're gonna find all of those. So we have the adjacency map now. And now that we have that information, we can loop over the adjacency map. So size underscore t movable equals 0. And we can go if adjacency map row call is fewer than 4, so less than 4, movable plus, and then stood C out, there are X. There are movable. And we crashed. Where did I mess up? Build around. Occupancy map, RC. That would be because these need to be -1s. There are 19 movable. 13 movable. Is that this needs to be less than or equal to? No. How do we go from decorating to spool lifts? Don't ask these questions. Where did I mess up? Let's actually make these size T's. And since this is a plus equals, we can just plus that. So let's print out the adjacency map. So we're gonna go stud C out adjacency map. Oh, there's another condition here, right? And occupancy map will call. A piece of paper is only a roll of paper is only movable if there's something movable there. There we go. On line 14, why am I setting R is less than or equal to max row? Because I also want to include max row. So since I'm adding 1 to the max row, right? I want to loop through that row. So, right, this is -1, this is +1, right? If I'm looping less than +1, that means I'm stopping on this row, right? So I want to loop less than or equal to, so that I stop on this row. Does that make sense? So we got 13. And now let's put in the big puzzle input. And we get 1, 5, 2, 3. And we get a gold star. Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklift might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they were repeating this process? Starting with the same examples above, here is one way you could remove as many rolls of paper as possible. Using highlighted @ to indicate that a roll of paper is about to remove, and using X to indicate that a roll of paper was just removed. So we're doing a fixed point calculation. Stop when no more rolls of paper accessible by a forklift. In this example, a total of 43 rolls can be removed. Yay, battery's happy. So we need a new step in here where we loop over the adjacency map and we set the adjacency values to 0. Doing no. No, we don't, because we're saying equal to the field around. So blue changed equals false. Actually, equals true. While changed equals false. And now we're gonna do these steps iteratively. So we're going to find the occupancy and calculate the movable. So I'm going to change this to removed equals 0. And if the removal conditions are met, an occupancy map row call is going to equal false. And removed, we're going to add 1 to. And changed is going to equal true. So we're going to keep doing this calculation until we don't change anything. And then we can say removed. What if you use recursion so that each time you remove a toilet paper, you check if the toilet? Because we have a big input here, right? And every recursive call tends to take space on the stack. So if we solve this problem through recursion, we're going to run out of space on the stack really fast, and we're going to segfault. So to avoid that, we're going to do this fixed point computation where we update our two maps. So we know what's occupied. And then from what's occupied, we're going to calculate how many are adjacent. And then once we know how many are adjacent, we're going to update how many should be occupied. And then now we have a new occupancy map, so we can recalculate what's adjacent. And we're going to keep doing this until we can't remove anything. Sound good? So let's test it on the small input. Does that answer your question? The not long-winded answer is so that we don't blow out our stack. Moved 43. Move 43, and now let's do it on the big one. Nine two nine zero. 9290. Yang. Hey, look, it's almost like I know how to do image processing. So the image processing puzzle is easy. Crazy how that works, isn't it? What's the next one? Is this one easy? As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left to put the wreaths up in the dining hall. Resolute in your quest, you investigate. If only we hadn't switched to the new inventory management system right before Christmas, another elf exclaims. You ask what's going on. The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of their ingredients are fresh and which are spoiled. When you ask how it works, they give you a copy of their database. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. For example, the fresh ID ranges are inclusive. The range 3-5 means the ingredient IDs 3, 4, and 5 are all fresh. The ranges can also overlap. An ingredient ID is fresh if it is in any range. Okay. The elves are trying to determine which of the available ingredient IDs are fresh. In this example, this is done as follows. Ingredient ID 1 is spoiled. It does not fall into any range. 5 is fresh. 8 is spoiled. Okay. Soft head pat, Donka. For this one, do we have to do range compaction? No. That's the elegant solution, but just checking all of the ranges is fine. How many of the available ingredient IDs are fresh? So day 5.cpp. You know, I said I was gonna stop like 2 puzzles ago, didn't I? Is that a Carter? Hi, Carter. Are you winning, son? Can't stop. I just got here. Wow. You want to watch me solve hard coding puzzles? You're not playing anything. I think that means you're winning, right? Okay. So we want a range. size T min max. I was decorating my house, making it festive. You stomped on a light bulb on accident. Oh no, is your foot okay? Stud, string, line. Wow, stud, get line from FN into line, and line dot empty is not true. Stud vector of ranges. But it's fine. Lost the battle. Well, I kind of assume that, right? Light bulb gets stomped, light bulb dies. The only thing in question here is does foot die too? Oh yay, foot no die. Actually, we can just make a range R. And then a char dash. And we can go stud I string stream from the line. S from the line. Now we can go S into R dot min dash R dot max. Well, foot may die later. I did stomp on carpet. Oh no. So now there's light bulb glass hidden in the carpet. That's not good. Did you like vacuum over it? And then we need to put that ranges dot push back right R. And now we need to go wow F in. We're gonna go stud vector of size T IDs. And we're gonna go F in into IDs dot push back dot in place back. Nice. It was mostly larger chunks and I think I got them all up. You should vacuum anyway to make sure that there weren't any small ones you couldn't see. So the foot doesn't die later, you know? Let's see out. IDs dot back. Okay, so let's. Did we put 5? We did, so let's check 5. And make sure that the last thing output is 32. Damn it. If I go IDs dot pop back, will that get rid of the extra 0? Yes. Nice. And just to make sure IDs dot front should be 1. Cool. So now I want to go for ID in IDs. And now I want to go for auto range in ranges. And we're gonna go bool contains value size T value. We're going to return min is less than or equal to value, and value is less than or equal to max. So if range dot contains ID, Then we break, and size t fresh equals 0. We increment fresh, and we break. But we have people over. I don't want to vacuum while they chat and everyone has shoes on. Well, that's fair, but don't forget to vacuum so the foot doesn't die. Also, why are you hanging out with me if there are people over? Let's see out. There were fresh IDs. There were 3 fresh IDs. The ingredients are fresh. That looks good to me. Oh boy, those are big numbers. We should still... Yeah, this is still small enough to brute force search. Okay. 613 fresh IDs. I got a gold star. They are playing a very specific battlefield, a very specific battle tabletop game. I'm a very nerdy boyfriend and I try to stay out of their way. I see. You have experience in C++ and I've started projects before, but I never finished one ever. Do you have any tips for short projects I could do so my GitHub profile isn't just unfinished projects? Tara, what are you interested in? One immediately easy answer, right, is if you do coding puzzles, right, like Advent of Code, shill. Those fill up GitHub. But those aren't exactly the best projects, right? I would, if I was hiring someone, I would want to see something a little bit more complete than just coding puzzles. Am I correct in assuming that if you found me, you're interested in game dev? They'll start bringing their spoiled inventory to the trash chute at the back of the kitchen. So they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient range is considered to be fresh. An ingredient ID is still considered fresh if it is in any range. Now, the second section of the database, the available ingredient IDs, is irrelevant. Here are the fresh ingredient ranges. So we have to do range compaction. So we're going to do range compaction and we're going to find all of the ranges. Game dev. So, let's hope the itch game jams. So itch has an almost overwhelming collection of game jams that are running right now. So what I would recommend is finding some game jam that's doing something you're interested in, right? And doing a game jam. You're pretty beginner still though, right? Nice beginner project if you're interested in game dev, right? There's 2 that I would point to. Run 1 is make a software rasterizer. So I have a video where we get started with a software rasterizer. Do, do, do. And I know how to spell my own name. I have a video where we get started with a software rasterizer. So I would start there. And then like make it better. So we show how to do triangles. Be able to like draw boxes and then be able to like interpolate normals across your cubes and do some like basic shading based on the normals in like a light direction. So that's one direction I would suggest taking. The other is there's a book called Ray Tracing in a Weekend. So I would work through ray tracing in a weekend. Do I even suggest adding onto this? Yeah. I don't have a suggestion of what to add, but find something to add onto ray tracing in a weekend and add something. And then beyond that, the obvious answer is to make a couple of small games. What? Actually, I should have asked this first. What side of game dev are you interested in? Because I'm interested in like the graphics rendering side of things. So I gave you some decent graphics projects. You're gonna have to say goodbye. It's 11 p.m. and you fell out your sleep at your desk. Oh no. Sleep well, battery. Thank you for stopping in. I'm assuming that the average answer to that is probably more of a I want to make games. And if the answer is I want to make games, 20 games challenge. I would work through the 20 games challenge. So the idea with the 20 games challenge is you make up, I think it's 10 games total. Yeah. And so the idea, right, is there's a set of games to pick here, right? And you implement one of them. And it teaches you something about game development. I'd pick a game engine to start with. If you want to do indie work, I'd pick Godot. If you want to work for somebody, so like not just make your own games, I'd pick Unity. And if you want to be crazy like me, I'd start making an engine from scratch. You're familiar with SDL? A mix of the graphics side and game design. Well, in that case, all of the projects I recommended so far are good. Make a nice software rasterizer. Make a ray tracer. Make your favorite set from the 20 games, right? Work your way up. And do it using SDL. I believe SDL has a renderer, right? Yes. I think. So you can either use SDL's renderer, or if you're feeling spicy and experimental, and like listening to some random anime AI shill its own stuff, you could use my renderer. That's I'm working on and starting to do some videos about. I think it has a nice API, but I have not had anyone else test that yet. But I've put a lot of effort into designing this to be simple. So if you're interested more in the graphics side, I would aim you towards something lower level like SDL or like Stylizer. Do software rasterizer, do ray tracing in a weekend, and then work your way up through the 20 games challenge in whatever framework you want. I might also point you towards Raylib. Raylib's another good choice. Does that answer your question? As I now need to soothe my throat since my throat's exploding. Also, honestly, being able to solve leak codes, I don't think tells me much about your skill. That just tells me that you memorized puzzles. So it basically tells me can code, yes, no. It doesn't tell me anything about how good you are at coding, if that makes sense. And me on topic, I now need to do some range compaction. So how the hell do you implement nice range compaction? So we want bool overlaps. So first off, we want bool contains. Do we? Contains range R. So return min is less than or equal to R dot min, and max R dot max is less than or equal to max. We can contain a range. So yeah, I think the overlap check will automatically do contains. So so min, so overlaps range R, return min is less than R dot max or max is greater than R dot min. Actually, am I correct? So overlaps is one of three conditions. So either I contain you or you contain me, or I contain one of your starts, or you contain one of my starts. I think I can simplify that. But we're not doing elegant solutions, we're doing solutions. Alright, is there a condition I'm missing in overlap? Either I'm a subset of you, or you're a subset of me, or I contain one of your starts, or you contain one of my starts. Okay. So stud factor range compacted. So for size underscore ti equals 0, I is less than ranges dot size plus I. So we're gonna go compacted. And we need one more. We need merge. So range, merge with another range. And this is just, we're gonna return stud min of min and o dot min and stud max of max and o dot max. So that's how we merge two ranges. So compacted dot pushback. Actually, we're going to in place back ranges I. And now auto C. I'm gonna make that a reference. And if size underscore tj equals I plus 1, j is less than ranges dot size plus j. Why is it upset? If but compacting 1 is a fixed point because so because if I start merging later ranges, earlier ranges that didn't overlap might now overlap. So we're gonna go auto last equals C. And so we're gonna go while C does not equal last. So range last C dot min not equal last dot min, and C dot max does not equal last dot max. So while there has been a change, we'll recompute the fixed point. I don't need J, so I can just use I again. Well, I do need I though. J is less. I don't. Why? Okay. And we're gonna go if C dot overlaps ranges J. Then we're going to say that C equals C dot merge with ranges J. And then we're going to go ranges dot erase ranges dot begin plus J. And then we're going to go Minus minus J. So I'm going to overlap. I'm going to check if any two ranges overlap. If they do, we're going to merge them. And we're going to keep doing that until we've erased every range that overlaps with this range. And then we're going to do it again, the next range. Okay. Sounds like I think this works. Let's check compiler error. Ranges. Oh, that'd be because I did not use 4. Okay. What should the demo compact down to? Just this one should disappear. The 12 to 18 was 12 to, oh no, 12. So 12 to 8, 10 to 14, 12 to 18, and 16 to 20 should all merge together. So we should wind up with 3 to 5 and 10 to 20 as our ranges. So let us check if the compaction worked. Oh, and I'm not updating last. So once this changes, last equals C. So compacted. So let's not do the fixed point here. Do the fixed point here. And after a compaction, so size underscore t acted equals 0. So wow, compacted does not equal ranges dot size. So now what we're gonna do is we're gonna go compacted equals ranges dot size inside each of these. We're gonna compact, then we're gonna go ranges equals. So we're just gonna keep compacting until another compaction doesn't change how many ranges we have. And we have ranges of the vector length 2, 3 to 5, and 10 to 20. So we have successfully compacted. And now the question is, How many ingredients are there total? So for each range, so size underscore t total equals 0, and so we're going to go for auto r in ranges, and we're going to go total plus equals r dot max minus r dot min, and we might need a +1 on that. Let's see. We're going to go total fresh IDs. And for this example, the total is 14. Do we have an off by 1? 12, yes. Let's put a +1 on there. 14. Let's go. And if we now put in the big data, how's that for a giant number? We got a gold star. Let's go. What's puzzle 6? After helping the elves in the kitchen, you were taking a break and helping them reenact a movie scene when you over-enthusiastically jumped into the garbage chute. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door has been magnetically sealed. As you try to find a way out, you are approached by a family of cephalopods. They're pretty sure they can get the door open, but it will take some time. While you wait, they're curious if you can help the youngest cephalopod with her math homework. Cephalopod math doesn't look that different from normal math. The math worksheet, your puzzle input, consists of a list of problems. Each problem has a group of numbers that need to be either added or multiplied together. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, each problem's numbers are arranged vertically. At the bottom of the problem is the symbol of the operation that needs to be performed. Problems are separated by a full column of only spaces. The left/right alignment of numbers within each problem can be ignored. So this worksheet contains 4 problems. Okay. Check their work. Cephalid students are given the grand total of adding together all the answers. So the grand total is that. Of course, the actual worksheet is much wider. You'll need to make sure to unroll it completely so you can read the problem clearly. So this is a matrix transpose problem. Matrix transpose and different operations problem. Okay. This is fine. I've been going for like 2 hours longer than I planned. So, I think we're going to call it for the day. And we're going to go see if anyone is live to be rated. I think I solved 2 puzzles since Carter got here, too. So, should we go there? Arlo is streaming. So I guess we're going to raid Arlo. Arlo Emery. Thank you, everybody, for watching. I believe that the next stream we're going to do is going to be with Russell. So on Thursday, Russell and I are going to start playing Dark Souls 3 together. And then on Saturday, I'm thinking that I'm going to do a little lecture on ray tracing. So if either of those things are interesting, Thursday, 6 p.m. Dark Souls, 6 p.m. Pacific. Saturday, 9-ish a.m. Pacific, ray tracing. Either of those things are interesting, then stop by. Thank you everybody for watching. Goodbye.